So in this question, we've got a box with a mass of 12 kilo being pulled by a rope, and in the rope the tension is 200 newtons and it's being pulled at a 50 degree angle to the horizontal plane. Now the coefficient of friction on the horizontal plane is 0.12. We want to calculate the acceleration. So first of all, let's draw a forces diagram. So that's our horizontal plane. This rectangle can represent the box and the mass is 12 kilos. Okay, so now I'm going to draw a line to represent the tension in the rope, which is 200 newtons at 50 degrees. So now draw a line there, magnitude 200 newtons and the angle 50 degrees. Okay, now the coefficient of friction is 0.12, so we know mu equals 0.12. So that represents the friction. Okay, now what we need to do is fill in all the forces acting on the box, apart from this one here we've already got, which is the tension in the rope. So one force we're going to have is the force of gravity. So that will be the mass of the box, which we know is 12, times the gravitational constant, which is 9.8 given in the question. Now, as this box is moving horizontally, there will be a resultant force acting on the box in a vertical direction to counteract this. So that'll be the normal force. We're just going to call that R. And as the box is being pulled this way, as there is some friction and also some resistance, the box will also have a resultant force in this direction as well, which we need to calculate. Okay, now let's do some calculations. So the box is not moving in any direction in a vertical up or down motion, so these two forces will be the same. So what we can say is that mg equals the force in the vertical direction upwards, which will be coming from the rope. Now to calculate that, if we make a triangle here, we can calculate the force in this direction will give us what's coming from the rope. So as it's opposite the 50 degrees, we'll use sine, and the magnitude is 200, so it equals 200 sine of 50 degrees. Now that's our resultant force R. So therefore R will equal mg minus 200 sine of 50 degrees. So we won't work this out just yet, we'll fill them at the end when we come to calculating our answer. Now, as this box is in motion, the forces that we can use is F will equal mu times R. Now that's the forces that we want to satisfy. Now F we're going to come to in a moment, but we know what R is and we know what mu is, so we can fill that in. So that's 0.12 times all of this, which is 12 times 9.8 minus 200 sine 50. Okay, now the force F, we can look at that. Now the force acting in the opposite direction to F will be the resulting force here. Now to calculate this force, it's adjacent to our angle, so we can use cosine. So cosine of 50 times 200. So therefore we can say that this force in this direction will be 200, let's write that down like that, 200 cosine of 50 degrees minus F. Now as we're calculating acceleration, we can use Newton's second law of motion, which says it equals mass times acceleration. So mass times acceleration will equal this force here, as that's the direction of travel of our box. So we want 200 cosine of 50 minus F, which is given here. So that's 0.12, 12 times 9.8 minus 200 sine 50. Okay, well mass we know what it is, that's 12, because that's the weight of the box. So 12A equals 200 cosine 50 minus 0.12 12 times 9.8 minus 200 sine 50. Bearing in mind we've not calculated any of this yet. So now to get the acceleration, we can divide everything by 12. So if I divide this by 12 and divide all of this by 12, this will cancel out, give us acceleration on its own. So if I put that into a calculator, I'll get that acceleration is approximately 132.8 meters per second squared to 1 decimal place. That will be our answer for this question. Okay.